Hi, and welcome to this lesson in thermal energy. Now, in this video, we'll talk about conduction, and we will look at three practical activities involving conduction and prepare some simplified reports on the experiments. Now, these reports are a very simple version of what you will be doing in Form 4 and Form 5. The format and the content will be the same, but we will be writing less details in these reports. So let's get started. Heat. In our last lesson, we talked about heat and heat transferring from one system to another. Now we know that heat is a form of energy. We also call it thermal energy. Now there are three types of heat transfer: conduction, convection, and radiation. Conduction is a transfer of heat through a material without the movement of the material itself. Heat is transferred within a material or from one material to the next, and this is done by kinetic energy being passed from one vibrating particle or an atom to the next. So do you remember what kinetic energy is? Kinetic energy is energy due to something in motion or because it is moving. It is due to movement. Solids generally conduct heat better than liquids and much better than gases. Materials that conduct heat easily are called thermal conductors. Metals are good thermal conductors. Poor thermal conductors are non-metals such as wood, glass, and plastics, and we call these thermal insulators instead. Now let's take a closer look at this heat transfer from one material to the next or within a material. And let's look at metal as an example. So we know that metals are solids. Their atoms are tightly packed together, very close together, as a solid should be. Alright. Now what is happening to metals is that we have free electrons that float on the outside of the atoms. Alright. So if we have done the topic on atomic structure, you would know that the electrons are on the outside of the atom. Now when these metal atoms are formed into a solid, we have these free floating electrons floating around the solid metal core, and we call this sea of mobile electrons. Now it is this sea of mobile electrons that cause metals to be very good conductors of heat and of electricity as well. Now this E with the dash is a shortened form of writing electrons. As we do chemistry and physics later on in the later forms, we will be using this symbol a lot to represent electrons. Alright, it's a generally accepted term with the examiners, and it could be used in writing the answers to solutions. Now when heat is applied to one end of this metal, these atoms gain enough energy to vibrate very rapidly. Now when they vibrate, they have kinetic energy. This kinetic energy is quickly passed to the nearby atoms, and heat is transferred very quickly from one end to the other end within the material itself. Now if there's another material touching this one, the heat from this material will then, when it reaches the end, the heat from here will then transfer to the atoms in the other material, and so heat energy is being transferred from within the metal and from one material to the next. Now, the time it takes for the heat to flow through a solid material is different. we say that heat flows at different rates through different materials. Now the word rate here, where we see this rate in mathematics, art math, or any other subject, it means the time it takes something to happen or something to occur, or that we are measuring something, one quantity, against time. Alright, so that's what this word rate means. So here, in our first experiment, we will be determining the rate of heat conduction of different materials. So to do this experiment online, we will be looking at videos of the experiment. You will now use the scientific method template on page 3 and complete that and submit as your assignment. Now I did the first experiment for you and to show you how it should be filled out and what needs to be put in there. Alright, so let's look at the first experiment. Our first experiment is to determine the rate of heat conduction of different materials. So we are going to narrow this down and we are going to do an experiment to determine which metal is the best and which is the poorest conductors of heat. And after viewing the experiment, we will go through the template for the scientific method and we will fill in our report. So let's take a look at that video now. So here is the experiment we are going to look at and we are going to determine which metal is the best and which is the poorest conductors of heat. So I'm going to start the video. So what we are seeing here is a Bunsen flame was placed below this setup here. Now we have this piece here at the bottom, this metal is the handle, that is where the person or where it is mounted to something else so that it's suspended in the air so that you can put the Bunsen flame below it. Now we have copper, aluminum, brass, steel and stainless steel. Now that is this here. Those are these metals here, right? Not the things attached to the end. So the steel rod, so it's a rod, a stainless steel rod, a copper rod, aluminum rod, okay? That's these here. So we have 1, 2, 3, 4, 5 metals attached at the center here, being suspended in the air by a handle, and there's a flame below it. Now, this is the point at which we are heating these 5 rods. Okay, so we are heating. Alright, so the speed of the experiment by 8. Alright, now we had something happen there. The object at the end of the copper fell off. Okay, so we could see that these objects were attached to the rods, so we could see this is wax, so copper fell off too. So you could take a note of that. Let's see which metal next the object falls off. Okay, so we had aluminum very quickly after. Aluminum. Start again. Oh, brass fell off pretty quickly after. Alright, so not too long after the object on the brass fell off. Now let's see between steel and stainless steel. As you can see, it takes a longer time. You see some movement on the steel and off the steel went. Okay, so your fourth, who came in fourth is the steel, and then last will be your stainless steel. Now we're going to put these observations into our report. Now let's take a closer look at our report. Our aim was to determine which metal is the best and which is the poorest conductor of heat. Right? And we have some marks allocated just to give an idea of how much these marks will be given in an actual report. So this is the question. So this is what our experiment is going to be answering. Now, in one of our previous lessons, we will have talked about variables in experiments, and you need to list what is independent variable, what is dependent variable, and what you kept constant in the experiment. In this case, the length of the rod of each metal was kept the same. The amount of wax you would place between the metal rod and the object will be the same as well. The size and shape of the object attached to the end of the rod will be the same, because we don't want to put a heavier or bigger size object on one rod and smaller sizes on the other, because that bigger piece will have a different weight and a different mass, and it will affect the experiment. Right? We want to keep the amount of heat we supplying to all 5 rods the same. So these are things we will keep constant or the same in our experiment. What was our independent? The independent variables are the one that we set. This would not change in the experiment, and we chose 5 different types of metal rods. So the material we used. The dependent is the time. That is what we measured or what we looked at. Okay, so we didn't actually sit and use a stopwatch to measure. All we needed to see was which one of these objects would fall first, and that would give an indication of which metal heat up first. The next heading in our experiment, our report, is the apparatus we use in the experiment. So, when we're writing up this part, so here we use 5 metal rods and we give the list of what material we used, and we use a Bunsen burner, wax, and 5 objects of the same size and shape. Our next heading will be a diagram of the apparatus and how we set it up. And a simple drawing would do. Usually you will need a title for your drawing. Okay, so you can put in a title for your drawing, but usually your title will be this. Okay, so in Form 4 and Form 5, you wouldn't have a box, like you wouldn't have a table like this. You will need to write the headings, okay, and put in the titles. So here, make sure to label everything in your diagram. Here we have the handle, we have the copper, stainless steel, brass, or aluminum. We have the wax, and we have objects, okay, attached to the end of each rod. I have my table here, and I have my Bunsen burner, and I labeled my field. Alright, so everything that you draw in your diagram, label it. And we would use pencil to draw with. We would not use colors unless we are instructed to. Now the next heading you would need to fill out here is procedure. Now this is the steps that you did in the experiment. Now here's a very simplified procedure. In Form 4 and Form 5 you need to be more specific. Okay, you need to actually say you are taking a drop of wax, attaching the object to the rod, and so on. But in this case, we would write set of the apparatus as shown in the diagram above. Record the order in which objects fall off their respective metal rods. And that's what we did next. Now here you can write in ascending order, if you want to be more specific. O-R-D-E-R. Okay? So in ascending order, meaning from the first to last. Now the results and observation is the next heading. The objects fell off the rods in the order of, and here is what you would write what you observe. So the copper first, aluminum, brass, steel, stainless steel was last. Okay? Now one thing that I didn't include here is precautions and the sources of error. Okay, and this we will go into more detail in each experiment and for each topic that we will do in Form 4 and Form 5. But an example of what a precaution is because we are dealing with heat. Now, the amount of heat supplied is something we would want to keep the same. We wouldn't want the heat to change during the experiment. So we would do simple things like close the windows, because we don't want breeze to be blowing into the room and cooling the surrounding areas faster. So we would close windows, we would turn off fans and ACs. Okay. So these are some precautions that we would take in this experiment. Our last heading will be conclusion, and this is the answer to your A. If you're not sure what to write there, go back and look at our A. We need to say which metal is the best and which is the poorest conductors of heat. And in full sentences, we will write the copper is the best conductor of heat, and we will say why. From our observations, the wax melted and the object fell off the copper rod first. Okay, so don't just write copper was the best and stainless steel is the poorest. For your 4 marks, you will want to write a complete sentence and say why, and that will be based on what you observed here for your results. Stainless steel is the poorest conductor of heat because the wax melted and the object fell off the stainless steel rod last. So this is the end of the first experiment. Right? So you can go back in the video and look at that again and see how we related what we looked at in the video to our report. Now, how can we prove that heat really flows through the metal and the wax didn't melt because of the heat from the surroundings? So, in our last lesson, we looked at heat flowing from the surroundings to a system or from a system to the surroundings. Now, how can we prove that the heat really flowing through the metal and not from the surroundings to the wax? So, our next experiment will be to prove that heat flows through a conductor. So, you would be recording the results of your experiment on the template on page 3, okay, and not in space 0. So, let's take a look at the experiment. So, the experiment is to prove that heat flows through a conductor. Okay, so we start with some apparatus materials here. We have a plastic bottle, paper, copper pipe attached to a wooden rod, and aluminum pan. So from the last experiment, we know that copper and the aluminum is going to be our conductors. The plastic and the wooden rod and the paper will be non-metals and they will be our insulators. So be sure to take down this as part of your apparatus and fill it into your table. Okay, so here we have this setup of our experiment, and in this first setup we are seeing stand and clamps. So be sure to label that and write it into your apparatus. We have a stand, and this is a report stand, and we have clamps. We have our wooden rod, paper, copper pipe, and we have our Bunsen burners. This one and that, and here we have our plates. Okay. So let's see what we are going to do. What is going to happen in this first experiment? So you're going to push the flame underneath paper and the wooden rod and the copper, and look at what's happening. We have the paper on the wooden side burning faster than the paper on the copper pipe. Magic? No, science, right? Could explain that. Alright, so what do you think happened there? Why did the paper on the wooden rod burn faster than the paper on the copper rod? Remember we were talking about atoms and the transfer of heat through the atoms. Alright, so we have our metal here. Because the metal is such a good conductor of heat, what is happening very quickly is that as soon as these atoms heat up, they transfer that heat quickly away throughout the entire metal. Alright, from this area to the area that is colder. Now, in the case of the wooden rod, because it is such a poor conductor of heat, that heat isn't going to transfer anywhere. Right? It's going to take a very long time for that heat to be transferred away. So because the heat is not moving away, the heat is going to remain right here and burn this paper. Okay? So you have the heat staying in this concentrated area, while the heat from here quickly flows away because metal is such a good conductor of heat. Right? Now let's take a look at the other experiment with the plastic bottle and the aluminum can. Alright, so let me just remove this drawing here. So we have the same equipment. Okay, the only thing changed is the plastic bottle and the aluminum can. We have our Bunsen burners, we have our flames, our stand and clamp. So let's see what happens when we put the flames under the paper with plastic and the aluminum. Okay, look how quickly that burns. Okay, so what do you think happened here? It's very similar to the last case, where because plastic is such a poor conductor of heat, that heat was concentrated right there, it stayed right there, it ended up actually melting the plastic and not conducting away from this area of high concentration. Alright? It burned so quickly that it caught the rest of the paper on fire. Right? We know that aluminum is a poorer conductor of heat than copper, but the paper still took a longer time to start to burn than on the plastic side. Alright, so please do not try these experiments at home. Do not try these experiments at home, okay? This was done in a lab setting with all the safety precautions taken place there, okay? So you are going to write up your experiment on your table. You're going to put the aim of the experiment, what we kept the same, what we changed, and the apparatus we use, the diagram of the setup. Okay, now when you're drawing this, you don't need to draw two sets of experiments. You could label copper or aluminum can. Alright, so copper rod or aluminum can on one side, and you could label plastic bottle or you could label wooden rod on the other side. Okay, all on the same diagram. Right, now in the procedure, make sure to state that you repeating the experiment. Okay, repeating the experiment for copper and the wood, and then for plastic and aluminum. Be sure to record the observations, which one started to burn the paper under which one started to burn faster, and then in your conclusion, state the answer to your aim with why that happened. Alright, and I gave you the explanation in the video, so you go back and take a look at that. Alright, so that brings us to the end of the second experiment, and we will take a look at the third experiment now. So for the third experiment, we know that we could boil water. We know that we could heat water, right? But is water a good conductor of heat? So now we're going to look at that experiment video, and we're going to write in your own words the short procedure, the conclusion of the experiment, and in draw a diagram, right? And we're not going to use this space below, we're going to use the table instead, okay, on page 3, right? The template on page 3. And we also have a question here. If wood is not a conductor of heat, then why do wooden houses burn so fast? Right? This question here is your research question. This is your research question. You will be submitting the answer to this in your assignment as well. Okay, so in experiment 3, we are going to determine if water is a good conductor or a poor conductor of heat. So this is our aim of our experiment. Now, all these experiments that we are doing is what we need to learn for integrated science and for physics later on if you do sciences in Form 4 and Form 5. Alright, these are experiments that you need to learn. You need to know how to plan an experiment, how to do an experiment like this, because these experiments could come in your practical exam. If you are a private candidate, it will come as a plan and design experiment. So they will tell you, plan, design an experiment to determine if water is a good or poor conductor of heat. And you will need to know your aim, list your apparatus, your variables, what observations you expect to see, what the diagram should look like, etc. Okay? So, this is not just to show you for fun. It is for fun, but it is on your syllabus for CXC and IGCSE exams. Alright? So, study these experiments well. Okay, so here we're seeing the setup of the apparatus. And here we have an ice cube at the bottom of this. Now this here is a boiling tube. Okay. Boiling tube. So in your Form 1 you should have gone through a list of all the common lab equipment. We have our clamp, our report stand, we have water. See, that should be yellow. We have water. We have a netting. This is to prevent the ice from floating to the surface of the water. Right? We don't want that ice to float up. So we have a metal netting here. And we have our ice cube at the bottom. Okay, so now we are going to place that Bunsen burner there. Just remove some of these things. So we are placing the Bunsen burner at the opening end of the tube. We are heating this water at the top here. Thermal energy from the heated water cannot be transferred to the ice cube by convection, as hot water is less dense and remains at the top. Okay, so we will talk more about convection in our next lesson. Right? Now here we are looking to see if this water molecules will conduct the heat all the way down to the ice cube at the bottom. Okay, so some time has passed. The water at the top starts to boil, but the ice cube at the bottom is not fully melted. Now this ice cube here would eventually melt because of the heat from the surroundings. If it is warmer, melting this ice, right? And the water itself has a temperature higher than the ice itself. Okay, so here we have that water boiling, and we still have the ice cube at the bottom. So this proves that water is a very poor conductor of heat, right? Even though we have this piece of metal here that you think would heat up and heat the ice, the water does not transfer that heat to the metal or to the ice. Okay. So this is a very short experiment that we do in school to determine if water is a poor or good conductor. Right? So that is what you would want to write up about in your template here. Right? I gave you the aim already. You saw the apparatus and the setup of the experiment. You will see what we kept constant. Okay? You would write up what we kept constant, what we measured, what we looked for, and what our independent variables were. Right? So you would write your observations and your conclusion, which is your answer to your aim. Now, in the textbook, I'm not sure which textbook you are using, but you should see similar experiments to these three, if not the exact same thing. Now, in this experiment here is another common experiment that you'll see in textbooks. And here we mixed experiments 1 and 2 together. So here we have glass, iron, copper rods. Alright, so we have non-metal and we have metals together. And we're heating all three the same Bunsen flame at the same point. And we're going to compare the rate at which matchstick drop, if at all. Alright, and you will conclude which, here you could conclude that metals do conduct heat better than non-metals. Okay, so this is another example of how you could do the experiment to demonstrate that heat flow at different rates through different materials. So that brings us to the end of this lesson, and your assignment for this lesson would be to complete the reports for the two experiments, experiment 2 and experiment 3, and submit those. And I will see you in the next lesson for convection.